Hi everyone, this is Lakshmipati V, Assistant Professor, Department of Computer Science, Ramaya College of Arts, Science and Commerce, Bengaluru. In this video, I will try to explain the concept of queue. See, under this queue, what are the concepts we'll cover in this video? Introduction to the queue, operations on the queue, array representation of the queue, types of queue, under the types of queue, circular queue, DQ, priority queue, applications of queues. Before going to the queues, let me know what is the data structure. Data structure is organized collection of data inside the memory. There are different data structures to store the data inside the memory, but always data structure is equal to organized data plus operations. Organizing means we can organize it inside the memory, then we can performing the operations. That operations are insertion, create, display, then traversing, deleting. See, these are the operations of data structures. See, data structure can be divided in two types. One is primitive data type, another one is non-primitive data type. Primitive data type is machine will be allocating the space for the variables. See, that is called a primitive data types. Under that primitive data types, character, integer, floating point number, double. We call it, that is a short form is char. Char will be allocating 1 byte of data. For example, we declared char a, means character a means a purpose, it will be allocating the 1 byte space. Integer, int a, the a value we need to store inside the memory, it will be allocated the 2 bytes. It is a accepting integer values. Then float means it will be allocating the 4 bytes. The double means double will be allocating the 8 bytes. See, this is a primitive data structure. Come to the non-primitive data structure. It is a mission independent but user dependent. User will be how much user wants. That much space will be creating for the variables. That is called a primitive data structure. See, under primitive data structure we will be dividing the two types. One is linear data structure, another one is the non-linear data structure. See, in this linear data structure means data will be stored in the sequence one after the other. Under that it will come for the arrays. Array is a collection of elements in same name and same data type. Then come to the another one is linked list. Linked list also it is in the sequence, but here data will be stored in the nodes. Each and every node will be dividing the two fields. One is information field, another one is link field. See, the link field is referred to always the next node address. Then it is also sequence. Then come to the stock. Stock also it is like a sequential data structure. It will be linear data structure. We can store the data inside the memory, but it is in the working mechanism is last in first out, but it is also sequence. Then come to the queue. See, queue also it is a linear data structure. We'll go for the next slide onwards. In the queue, then non-linear data structure means it is not depending the logically adjoint elements. See, tree and graphs are non-linear data structure. But in this video we can try to explain the concept of what is queue, then how to represent it in the queue, then what is the working mechanism of queue. The working mechanism of queue is first in first out. See, queue is a linear data structure. Queue is a linear data structure. Can see this one, but in this diagram queue also declared like a arrays. See, declaration is int queue of 5 means it will be allocating the 5 memory blocks in sequence. But in this diagram we declare the queue of 6, say queue of 7, but see it is queue of 0, queue of 1, queue of 2, queue of 3, queue of 4, queue of 5, queue of 6. But it will be 7 blocks of data is there in this diagram. But here working mechanism is first in first out. The working mechanism is first in first out, means which data element will add first to the memory, that will be deleted first. See, that is only the, but where you can add, that end is called a rear end. Where you can delete, that end is called a front end. Where you can delete, that end is called a front end. See here, a new element is added at one end is called a rear end. Existing element deleted from the other end is called a front end. Here, when you are implementing the queue mechanism, the insertion deletion takes place two different ends. Insertion end is called a rear end, deletion end is called a front end. See, that is only the queue. Then see insertion. See, for example, see the place a item in a queue is called a insertion. See, it will be added in the rear end. See, rear end itself. But here, see, for example, in the real time we are following the many queues. For example, you go for any one movie hall. See, there we can buy the ticket. So either you can go for the bookstore. We follow the queues. We will be first. They will be pay and buy the ticket first. See, that is only the queue. See here, this side we can add it, then it will be moving front side. See, that is only the which is added first, that will be deleted first. Insertion will be always do it in the rear end. Then come to deletion. Removing an item from the queue is called a deletion, which done at other end of the queue is called a front end. See, we can always deleting in the front end. Then see array representation of queue. For example, see it is a queue a of 0, a of 1, a of 2, a of 3, a of 4. See here we declare the int a of 5, means it will be allocating the 5 blocks of memory. Array start with 0, end with n minus 1. See here 5 minus 1, it is n is equal to 5. Then it is a 5 is the size of array. See here it will be allocating the 5 blocks of space. The first value it is occupying a of 0, second value is occupying a of 1, third value is occupying a of 2, fourth value is occupying a of 3, the fifth value is occupying a of 4. See, one end is called a rear end, another end is called a front end. See, where you can delete, that is called a front end, where you can add, it is called a rear end. So always when we can go for add, that time we do the rear plus plus. When you can delete, that time we can also do the front plus plus. See, in this diagram, in the second diagram of this slide, queue after insertion of the new element. See, initially it is rear will be element it will be, it is a maximum is a of 3. Then if you go for adding one more element, rear will go for finding the last location. If you are deleting one element from the queue, see, that is called a 9. See here front will be showing the another one location. See, it will be free from the this one. Here one drawback is there. Your front is here means always we display the values here onwards. Then at this space is not using on the time. It is free also. Once the rear will be reached the n minus 1, it shows the queue is full. See, that is only the drawback. Then see this diagram. Here the back will be rear. See, using the back we can go for adding the elements. The back will be incrementing. You are deleting, the front also incrementing. Then once it is reached the end, then we can give the back, it will come to the 0. This is the way working mechanism of queue. See, once we initialize, after reaching the back n minus 1, that will be queue is full. Then we need to reutilize the previous that one. That time we can give the, see, back once reach the condition of n, then we assign that one to the 0. The front is less than back. See, that is only this one. See, front is not equal to 0, that time front is in the other location, then we assign the front. See, this is the working mechanism of queue. Then come to the algorithm to insertion on element in the queue. Then first we'll check the condition. Rear is equal to maximum minus 1. Maximum is n. Either if you take the 5, then rear will be 5. The 5 minus 1. 5 minus 1 means rear is equal to 4 because it start with 0. 0, 1, 2, 3, 4. See, it is rear is equal to maximum minus 1. Initially rear is equal to minus 1. Front is equal to minus 1. See, this condition is true, then we can go for writing a queue is overflow, then it is exit. Queue is overflow means we can't add any element to the queue. Then rear is equal to minus 1, that time front and rear is 0, then queue of 0 will go for adding the element. See, this condition is else, then we set that one rear and front is equal to 0, then we can go for queue of 0 will be item. Else this condition is also false, then we can go for, see, this rear is not equal to minus 1, then it will come for else part. we increment the rare is equal to rare plus 1, because rare will be 0 or rare will be 1. See, that time we can go for 1 0. For example, rare is 0 means you have one element already, then we can go for adding 0 plus 1, then it will go for 1, q of 1 is equal to item. Then rare will be 1. If you go for adding one more element, rare minus 1 condition is false, it will come for else. Then we can go for 1 plus 1 is 2, then q of 2 is equal to item. See, this is the way we can go for tracing. Do one thing, see, you can pause this video, then take the sheet, then you can using these steps, then create int a of int q of 5. You can create a table 5 nodes. Then initially you can check this condition is false, then you can go for the step 2, that condition also. Initially rare minus 1 condition is true, then we can assign the front and rare is equal to 0. We can add one more element to the queue. Next, keep repeating that one. When rare will go for 4, that time it's overflow. This is only the insertion of queue. Then come to the deletion. See, algorithm to delete an element from the queue. See here, when you can go for deleting and insertion, you require for the 5 parameters. First is queue, front, rare, number of elements, then which element you need to delete. See, this is also same thing for the insertion also. See, when you can't delete, see, you can see first under the check that one, rare is equal to front minus 1. See, it is less than front, that time you have no elements in the queue. See, that time it is underflow. See, it is underflow. We can't delete any element from the queue. Then item is equal to queue of front, means which, see, this condition is false, that time if you have number of elements, then first element will be deleted where the front is located. For example, front is minus 0 means we have deleted first element. Front is 1 means it is deleted second element. Front is third means it is deleted the, so front is 2 means it is deleted the third elements. Then front is equal to rare means you have only elemented, that time front will be 0, rare will go for minus 1. Else front will be incremented front plus 1. For example, this condition is false, you have many elements in the queue. See, that time it will go for front is equal to front plus 1. Then this condition is true, see, you have only one element in the queue, that time front will be 0, rare is equal to minus 1. See, this is only the deletion of the deletion algorithm. Just this also you can try to trace this algorithm. Then come to the types of queues. DQ, circular queue, priority queue. See, DQ means double-ended queue. See, we can do the insertion and deletion in both sides. For example, see this diagram. See here, the front and rear. See, in the already actually in the queue, the front end itself only deletion. Queue rear end itself we can go for inserting the elements. But in the when you can apply the concept of double queue, we can go for insertion and deletion will take place in the both end. See, that is only the DQ. The DQ will further dividing the two types, input restricted queue and output restricted queue. The input restricted queue means, but here input restricted, deletion will take place the both end, front end and rear end. Insertion will be do it only in rear end. Then output restricted queue means the insertion will be do it in the both the ends, then deletion will be takes place only the front end. See, in the input restricted, the deletion will be do it in the both the ends, the insertion will be only in the rear end. Then come to the output restricted DQ. See, that time insertion will be do it in the both ends, the deletion will be do it in only rear end. Then come to the circular queue. Circular queue means one drawback in the normal queue, linear queue. See, when the rear will be reached the n-1, see, that time queue is overflow, but front will be the 3. For example, the queue size is 5, the front is 2, means this location, you take this location, queue started with 0, already these two elements are deleted, front will come to the here, the rear will reach to the 7, that time what will happen? See, it shows queue is overflow, but you have space of 2. See, you have space also, they are showing the queue rear will be n-, already you see the previous slide in the insertion, when the rear will is n-1, that time queue is overflow. See, then overcome that problem, that problem. For example, front is not equal to 0, that time rear will assign to the 0. See, that see, that is only the circular queue. Circular means it is connected, when it is rear will reach the n, automatically it will go for the rear will be 0. See, that is only the circular queue. Then see, you can go for implementing the circular queue concept. The front is equal to rear plus 1 percentage max. For example, the front is 2, rear is already 7. Rear plus 1, 8. 8 modulus of 8. The maximum is 8. What will happen? See, rear will start 0. See, rear is 7. 7 plus 1 is 8. Modulus of 8. See, that time it is 0. See, it is not equal to that. It is front also 0, rear also 0. Then it is overflow. See, we have already everything is full. Then for example, front is 2, rear is 7. Means rear will reach the 7. That time this condition is false. That time we assign the front is equal to -1. The rear and front is 0. The rear is equal to rear plus 1 percentage maximum. Then it will be reach that condition. See, this condition is true. That time front is 0, rear is 0. You have only already q is overflow. You can't add one more element to the q. When this condition is false, then front is -1. That time rear and front also both are 0. Then we'll check the condition. We can go for the adding a one more element to the q, that is cq rear is equal to item. We assign the rear is equal to rear plus 1. For example, rear is 7. See, this condition is false. Rear is 7. 7 plus 1 is 8. 8 modulus of 8 is 0. Now rear is equal to 0. Q of 0 is equal to item. When it is not equal to 0, that time front will be in the 5, 6 anywhere. That time we can go for adding one more element to the circular Q. See, it is very clear. See, front is equal to rear plus 1 percentage modulus of maximum. For example, you take the size of Q is 5, the rear is 4, the front is 0. Front is 0. Front is 0 means, for example, see here, when it is front is 0, then rear is reached to the final. That time already all the data fields are occupied. You can't go for adding one more element in the circular Q. Then avoiding that one, for example, you have free space, already two elements is deleted in the Q. That time already rear will reach the final location. See, rear will be already in the 7th. This field, rear is already here. The front is in the 2nd. That time you have two spaces. That time only we apply this algorithm. See, this condition is true. That time front is equal to rear, front is equal to 0. That time the condition is true. It is overflow. You have no elements in the, you have no space in that Q. But condition is false. Then we'll check the if front is equal to -1, rear front is equal to 0. Then else we can go for applying the condition is rear plus 1 modulus of maximum. Then Q of rear. Then we assign this condition is false. That time we can go for check that one, rear plus 1 modulus of maximum. That time, see, for example, rear is 5 means 4 plus 1 5 modulus of 5. Then rear will be 0. Then we go for adding the Q of 0 is equal to item. For example, front is 2. Then we check that, and if condition front is -1, condition is false. See, that time front is 0, condition is false. When it is 0, front is not 0 means that time it is there in the other location. Rear is equal to 1 plus. For example, rear is equal to 0 plus 1. Then now plus 5 means it is a 1. Then Q of 1 will go for adding the element. This is the way we can go for adding the circular Q. Then come to the algorithm to delete any element from the circular Q, CQ. In the front is equal to -1. See, front is equal to -1 means it is underflow. You have no elements in the Q. The front is equal to rear. Rear means then we assign the front and rear is equal to -1. We can go for deleting that one. Either you can go for front plus 1 modulus of maximum. You need to go for deleting that one. We use the front is, for example, 2 means 2 plus 1 is 3. Then modulus of 3 means 3. We can delete the 2. Then it will be assigned to the 3. This is only the circular Q deletion. Then see, this is the implementation of circular Q. How they can see, once it is reached the 7th location, if you deleted 0, then once again it is occupying the AF0. It keep repeating when the spaces are available. The space is not available, then it will be showing the overflow. Then no elements in the queue. That time we can't delete the element. If you have elements, then we can go for doing that one. See, that is only the implementation of circular Q. Removing also start with 0, then adding with rear end, deleting with the front end. See, we'll check the condition when rear and front are equal, then Q is circular Q is full. Then purity Q. See, purity Q means it is highest purity. We can apply the according to, we can insertion will be do it in the normal linear Q. When we can go for deleting based on the purity basis. See, that is only the purity. It is a collection of elements where the elements are stored according to their purity levels. Insertion removing of the elements from the Q is decided by the purity of the element. Any element of highest purity is processed that in the first. The two elements in same purity will apply the condition is first in first come. Then come to the applications. The real world application, the cashier line. The see, for example, when you can go for the cash, when pay the bills in the store. See, cashier line in any store, waiting on hold for the tech supports, people on the insulator, then check out at any bookstore. See, these are the real-time applications. Either you can go for any temple, either you can go for movie ticket, either you can go for the railway ticket. All these are the real-world applications. Then come to the application related of the computer science. When the data is transferred for asynchronous between two process, input-output buffer, when the resource is sharing among the multiple customers. Example, CPU scheduling and disk scheduling. CPU scheduling means first come first serve. Disk scheduling also it will be first come first serve. See, that is which data, which process will come first, that will be allocated first. See, that is only the queue mechanism is first in first out. In recognizing of the palindrome, the sharing the resource of management. For example, take the printer will be give the first printer in the cyber center, they only get the printout first. Keyboard buffer, round robin scheduling, the job scheduling, simulators, everywhere we apply this queue concept for applying the for performing the task. These are the applications of related to the computer science. Thank you for watching this video.